Hello, grade 8. This is Mrs. Lopez, and we are working on lesson 2 in our module 4 today. Before we start on that lesson 2, I just wanted to remind you something from grade 7 that we studied earlier last year. Here in front of you, you have an expression 2x plus 1. This expression has two terms. A term is a number and a letter or just a number that is separated by the plus sign. So terms are separated by the plus sign. By plus sign. So this expression has two terms, 1 and 2. Two terms. Coefficient. Coefficient is a number that stands next to the letter or multiplied by the variable. A number multiplied by the variable. Okay, so in this expression, 2 is the coefficient because it's multiplied by the x. X is the variable. Coefficient. 2 is the coefficient. Constant is a number that, just a number. It's by itself. There is nothing next to it. Standing by itself. So 1 in this case is going to be a constant. Okay, so in this expression we have two terms. 2 is a coefficient, 1 is a constant, x is our variable. Now there is also something that is called like terms. Like terms. Like terms are the terms that have the same variable. Terms that are constants or coefficients with the same variable. Okay, so if I, for example, had 2x plus 3x, you would have two like terms. And these terms we can combine because here I have 2x and I have 3x. Together it makes 5x, right? If I had 4x plus x, coefficient of this x is 1. This is 1x. And 4x plus 1x makes it 5x, right? So I can combine them. In this case, in my original example, 2x plus 1, there are two terms, but they are not like terms. 1 does not have an x next to it, and 2 does, right? So I cannot combine them. They're not the same. Okay, so this is a basic information that you need to know before we move on to lesson 2. Let's look at that lesson 2, and in front of you, you see the examples. You don't have them on you, but you can follow along and make sure you understand it before we get to the exercises. Okay, so number 1, a linear expression. So something new that you will see here today. A linear expression in x is an expression where each term is either a constant or a product of a constant and an x. For example, the expression 57 minus x is a linear expression. However, the expression 2x squared plus 9x plus 5 is not a linear expression. Let's look at the definition of the linear expression one more time. A linear expression in x is an expression where each term is either a constant, so just a number, or a product of a constant and x. We don't have x multiplied by itself. X will not have an exponent on top of it. Okay, it can be exponent of 1, x used by itself, but nothing else is going to be a linear expression. So why is 2x squared plus 9x plus 5 not a linear expression in x? Because the term 2x squared has an exponent of 2 on top of the x. If it was used without that 2, then it would be a linear expression. But because there is a 2 there as an exponent, there is a second power, this is not a linear expression because one of the variables has an exponent of 2. Has an exponent of 2. That's why we can't use it in as a definition of the linear expression or example of a linear expression. Let's examine the expression 4 plus 3x to the fifth power more deeply. To begin, we want to identify the terms of the expression. How many terms are there and what are they? So the terms are separated by the plus sign, remember. So we have two terms here, 4 and 3x to the fifth, because they are separated by the plus sign. So two terms, 4 is one of them, and 3x to the fifth is the second one. How many terms comprise just constants and what are they? So what are the just constants? Constant is just a number and that is one term 4. That is just a number. How many terms have coefficient and what are they? Coefficient is a number multiplied by the variable. In this case, we only have 3 is a number that is multiplied by x to the fifth. So that 3 is going to be the coefficient. So one term, 3. Is 4 plus 3x to the fifth a linear or nonlinear expression in x? Why or why not? Okay, so this is a nonlinear expression in x because x has a power of 5. Nonlinear expression because the variable has a power of 5. How many terms, number 3, how many terms does the expression 7x plus 9 plus 6 plus 3x have? What are they? Simplify the expression and decide whether it is a linear or a nonlinear expression. Okay, so let's go one question at a time. How many terms does the expression have? Let's look at the terms that are separated by the plus sign. 1, 2, 3, 4. 4 terms, and these are the terms. So 4 terms, 7x is one of them, 9, 6, and 3x. These are the terms. Now we need to simplify this expression. I will rewrite this expression one more time. 7x plus 9 plus 6 plus 3x. All of them have a plus sign, so I don't need to change subtraction into addition or anything like that. I want to look at the like terms. And the like terms have the same variable or they're just constants. So I see that I have 7x's and I have 3x's. If I put them together, I will get 10 of them, right? So I will have 10x plus, and I can combine 9 and 6 because I know how to combine 9 and 6. 9 and 6 is 15, right? So your simplified expression will look like 10x plus 15. Is it linear or a nonlinear expression? This is a linear expression because x is used to the power of 1. It's only used once, okay? Linear expression. The variable is to the first power. Okay. Number 4. How many terms does the expression 5 plus 9x times 7 plus 2x to the ninth have? What are they? Simplify the expression and decide whether this is a linear or nonlinear expression. Okay, so let's look at the terms. Terms again are separated by the plus sign only. Okay, so here I only have 3 terms. Even though I have 4 numbers that are used, I have only 3 terms. 5, 9x times 7, and 2x to the 9. So 3 terms, 5, 9x times 7, and 2x to the ninth. Okay, simplify the expression. So let's go ahead and simplify. I will rewrite that. 5 plus 9x times 7 plus 2x to the 9. Okay, so in this case, 9x times 7 is 7 groups of 9x. If it's like I took 9x's and put them together 7 times. So I can multiply 9 and 7 because it's 7 groups of 9x added together, right? So I will have 5 plus 63x plus 2x to the 9. There is nothing else I can do here because all these 3 terms are not like terms. I cannot add them together. Okay, is it a linear or a nonlinear expression? This is a nonlinear expression because one of the variables have a power of 9. Nonlinear expression because one of the variables has a power of 9. Okay, number 5 is 94 plus x plus 4x to the negative 6th minus 2 a linear or a nonlinear expression in x? Why or why not? Okay, so here they're not asking you to identify the terms or anything like that. They assume that you already know it. So go ahead, let's go ahead and simplify that, and then we'll figure out whether or not it's linear or nonlinear expression. First of all, I see minus 2. Right away, I want to change it into add the opposite. So I'm changing subtraction into addition of the opposite, negative 2. Now I see that 94 and negative 2 can be combined because they are constants and I can work with constants. 94 plus negative 2 is going to be 92. And there is nothing I can do more than that because these are not the same. X is to the first power and x is to the negative sixth. So I will just write them as is. X plus 4x to the negative sixth. And this is a nonlinear expression because one of the x's has a power of negative 6. Nonlinear because one of the variables has a power of negative 6. Okay, last one here is x to the first plus 9x minus 4 a linear or nonlinear expression in x? Why or why not? Okay, so here they want to confuse you. They put an first power above the x. X to the first is x by itself. And 1x plus 9x will give you 10x minus 4. 10x minus 4 is a linear expression because x is used to the first power. Linear expression because the variable is to the first power. All right. These are all the examples, and I hope you understand them. Now let's look at the lesson itself and your exercises. I would like you to try them on your own. It does have. Let's actually do one together just to make sure you understand what to do here. Um, where you need to write each of the following statements as a mathematical expression. So they take your lesson one and they add a new level to it. So you're not only transcribing these words, sentences, and making them an expression, but you also decide whether or not the statement that you will make a linear or a nonlinear. If it's a nonlinear, you need to explain why. Okay? So let's go ahead and do the first one together, and then you will pause the video and do it on your own. The sum of a number and 4 times the number. The sum is going to be a plus sign, and number is going to be your x, and 4 times the number is going to be your 4x. So you're going to combine x and 4x. So let x be the number. You always need to identify your variable, otherwise we don't know what you're talking about. Okay, so now you have x plus 4x. Since these are like terms and they both have x's, you will have 5x. 5x. 5x has only one term, but even though it's just one term, x is used to the first power. It means this is a linear expression. All right, so go ahead, pause the video, do the rest on your own, and then we'll get back together and look at the answers together. Okay, so number one, you have the sum of a number and 4 times the number. Let x be the number that we don't know. 4 times the number is going to be 4x. The sum means I need to add them together. So x plus 4x. Since they're like terms, I just combined them and I got 5x. 5x is a linear expression because x is used by itself or to the first power. Number two, the product of 5 and a number. A number is an x. 5 multiplied by it is going to be 5x. It is a linear expression. Number three, multiply 6 and the reciprocal of the quotient of a number and 7. Quotient is the answer to a division problem. So you are dividing x and 7. So that looks like this, x divided by 7. The reciprocal is going to be flipped fraction. So that will be 7 divided by x. Now you're multiplying 6 and that looks like 6 times 7 over x. That is actually a nonlinear expression because if I simplified it further, I would have 42 over x or 42x to the negative first power. When we have x in the denominator, it means that x has a negative power. So 42 times x to the negative first is a nonlinear expression. Number 4. Twice a number subtracted from 4 times a number added to 15. So I put 15 in the beginning because you're going to add everything to the 15. So 15 plus, and then x is the number, twice a number, so 2x, subtracted from 4 times a number. So 4x minus 2x, and that is going to be added to 15. So 15 plus 2x is going to be our expression, and that is a linear expression. Number 5, the square of the sum of 6 and a number. Sum of 6 and a number is 6 plus x. Square of it will be 6 plus x in the parentheses with the square sign. That is a nonlinear expression because when I multiply 6 plus x by itself, 6 plus x times 6 plus x, I will eventually get x that will be needed to multiply by x, which is going to be x squared. And that is a nonlinear expression when I have an x squared. Number 6, the cube of a positive number divided by the square of the same positive number. A cube of a positive number is going to be x to the cube, to the third power, and you're dividing it by the square, or x to the second power. When you're dividing third power by the second power, you can simplify what you have and you will have only one x left, and that is a linear expression. Okay, next one, the sum of four consecutive numbers. So a first number is an x, second consecutive will be x plus 1, then x plus 2, then x plus 3. When you simplify them all, because you have plus signs in between everywhere, so you combine all the x's, you get 4x, and you combine all the constants and you will get 6. 4x plus 6 is a linear expression. Number 8, 4 subtracted from the reciprocal of the number. If x is the number, then the reciprocal of x is going to be 1 over x, and that is x to the negative first power. 4 is subtracted from it, will look like x to the first minus 4. That is a nonlinear expression because x has a variable of negative 1. Half of the product of a number multiplied by itself 3 times. Half of the product of a number, so it's going to be a number multiplied by itself 3 times, it's x to the third power, and half of it is going to be x to the third power divided by 2. That is a nonlinear expression because x is to the third power. Number 10. The sum that shows how many pages Maria read if she read 45 pages of a book yesterday and 2/3 of the remaining pages today. So this one is a little tricky because if x is the number of pages in the book and she read 45 pages yesterday, so she today read less than 45 pages, x minus 45. Right? 2/3 of that is going to be 2/3 of x minus 45. And you want to show the sum of how she read yesterday, how much it was 45, and that will be added to how much she read today. X is the original number of pages, minus 45 is what she read yesterday, and 2/3 of that is going to be how much she read today. That is going to be a linear expression because you're not multiplying x by itself or anything like that. X is only used once. Admission fee of $10 plus an additional $2 per game. X is the number of the games. 2x is going to be $2 times the number of the games, and plus $10 your admission fee. 10 plus 2x is a linear expression. And number 12, 5 more than 4 times a number and then twice the sum. X is your number. 4 times the number is going to be 4x. 5 more than 4 times the number is 5 plus 4x. Twice the sum is when you need to multiply this sum by 2. That is a linear expression because x is only used once. That is our lesson 2. I hope it's not too confusing. If it is, please review your rules of exponents. That is the one you want to look for. And message me if you have any questions, and I will talk to you in the next lesson.